Assalamu alaikum. Good morning, everyone. Today we are projecting about support vector machine or SVM. Myself, Faisal Ahmed, and my teammate Ontu Dash. We are very excited to guide you through this topic. So, welcome to our presentation. First of all, what is SVM? SVM is a supervised learning algorithm used for classification and regression problem. So there will be a given data set like this, and here is a circle and a square shape data in this data set. So we will separate them by using a best hyperplane. Why is it called a supervised learning algorithm? Because of we will we will have a level data, and we will train them and separate the different classes. How SVM works? First of all, we have to find a best hyperplane. The decision boundary for separating the classes is called hyperplane. Here is a two types of classes. Here is circle and square shape. We just use a hyperplane and separate the different classes. Next is support vector. What is support vector? Support vector is the closest point to the hyperplane. Here is the closest point for hyperplane is this one, and for square this one. So next we will use a margin. What is called margin? The distance between the hyperplane and nearest data set. So here is the margin is the distance between the hyperplane and support vectors. So our main goal is to maximize the margin for better generalization. Here is, we can also find a margin, but this one is not better option because of there is not have a maximize the support vector. For more efficient for the separating the different classes, we have to find the best hyperplane and best margin. Here is, we find the two support vector, and here is also find the three support vectors, and the distance between the support vector or margin is more large. So this will be more efficient for separating the classes. Types of SVM. Based on the nature of data set, there is two types of SVM. First of all, linear SVM. Linear SVM separate the data used a linearly line. Use a straight line like this. Here is two data set. We just use a straight line and we separate the data set. And next one is nonlinear SVM. Nonlinear SVM, we can't use a straight line. So we have to use a kernel function for this data set. The common kernel function for separating the nonlinear data set is called RFD, polynomial, and sigmoid. So next, my teammate Ontu Dash will explain the other part. So Ontu Dash, please.
Thank you, Faisal Ahmed. Now I will discuss about the kernel function. So why we use kernel function and what is the purpose of kernel function? So the purpose of kernel function is to transforming the non-linear data into a higher dimensional space. So we can see there are many linear data set and which is in 2D dimension. By using kernel function, we can transform this dimension into a higher dimensional space. So there are many types of kernel functions. So we will discuss about major kernel functions. First one is linear, and second one is polynomial and Gaussian or radial basis. It's also known as RVF. And last one is sigmoid. So this is the decision boundaries in SVM, kernel SVMs. This is for linear, and this is for polynomial, this is for RVF, and this is for sigmoid. So at first, I will discuss linear kernel. So why we use linear kernel? This is a class and this is a class. We can separate this class easily by using a linearly separable hyperline. So this is the function of this. So we can use in code a classifier for linear function kernel equal linear. So next, polynomial kernel. So it allows for modeling a curved decision boundaries by raising input features to a specified power. So this is the equation of for this kernel function. So here D is the degree of polynomial which determines the flexibility of the decision boundary. So we use the classifier in SVC function kernel equal poly and the degree of 4. Gaussian kernel, also known as RVF kernel function. It's highly flexible and can model complex decision boundaries by considering the distance between feature points in the input space. It's particularly effective for linear datasets where the separation between classes is not linear or polynomial. So it's not linear and not polynomial. So in this case, we use Gaussian or RVF kernel. So here is the equation for Gaussian kernel. Here, this is gamma, which control the influence of each individual training sample on the decision boundary, and which classifier is used, kernel equal RVF for any random state. So last one is sigmoid kernel. It's also known as hyperbolic tangent kernel. So this is the figure. So here is a equation for this function. Here alpha is a scaling parameter, C is a bias or offset term, and tan h is hyperbolic tangent function. So using the classifier for this function kernel equal sigmoid. So now discuss the application of SVM in classification, spam detection. In our mailbox, regularly we gauge so many email in our mailbox, regular email, spam email. So it's mandatory to classify those emails. So by using SVM, a model can easily classify the regular email and spam email. Image recognition can also be performed by using SVM. And for regression, it can predict the stock price and forecast the weather. In medical diagnosis sector, by using SVM, cancer can be detected or disease can be classified. So we'll discuss about the advantages of SVM. It's effective in high dimensional spaces, work well for clear margin separation, versatile with different kernel functions, and memory efficient. So limitation of SVM, sensitive to outliers. When model get a extreme data point, so it's create an impact on our model, so it's sensitive to outliers and not suitable for very large data set. So for very large data set, we use deep learning. So it's not suitable for very large data set and requires careful kernel and parameter selection based on the nature of data and the problem in our hand. This is implementation. We use this code for gigs per gig, from gigs per gig. So this is a Python code we used. So we take a data set, breast cancer. It's actually the data set of cancer cell or regular cell. So we load the data set and trained them by using SVM function and train our model level data set. So by using the kernel, here we use the types of Gaussian or RVF function. So here is the output. So this is the condition. So this is as like cancer cell, which is separated from the regular cell. So there are many similar topics to SVM, artificial neural networks and ANN, random forest, logistic regression. So if you have any question, feel free to ask or comment on the video section. So thank you everyone for your attention.